Hi everyone. So yeah, Esmond, thank you so much for reaching out to our team to let us come to this event. We're super excited to be here, even though it's in spirit for the rest of my teammates. But before I dive into the specifics of the project, I'll just talk a little bit about our process. So in terms of like really concrete things that I can like say without trying to be fluffy, the thing that our group focused on within the hackathon is just like starting with like what are the ideas that we want to like test out, and then having each person run different prototypes of that, and then meeting up very quickly. And very much just like really trying to run as many small scale experiments as possible, and then that way we know which one to scale up, right? And then also we really were trying to like figure out who else can join the hackathon late into the hackathon. We actually had like a team member join the second day, and it made a big difference. So like definitely don't be afraid to reach out to your friends. And then in terms of like, maybe like hardcore coding setup, we use Visual Studio Code with Copilot to like really kind of like speed up as much as possible. And then we also made sure that we had, like the right amount of like perfect, like really good usage with like a debugger. So I mean, like not just like print statements. And the reason that's important is because then you can build out like multiple pieces of your code that are going to interact with each other, right? But then you can like test each file to make sure it runs as expected. And that's important because like at least like within this project, the code base got like really big really quickly. Multiple files interacting with each other, and you don't want to press play all at once. You want to be able to test each part iteratively as you're putting it together. So that's like hardcore coding stuff. Any questions there that I can answer quickly? If not, then I'll go into like more team dynamic things that are, important. Um, so I think from team dynamics, like having specific roles for each person is also really important. Figuring out what each person should focus on in terms of like, okay, I'm just gonna do a literature review and like go ham. Okay, I'm just gonna do like coding. I'm just gonna do like, testing. And then that way, like, you can have really each person contribute 100% of what they're doing, and there's no downtime. And yeah, so I'll probably speak more to the end, but let me just kind of go through this. So my name is Juan Pablo Rivera. I worked on the escalation risks from large language models in military and diplomatic scenarios. So the other co-authors, Gabe McCoby and Ankur Ruel, were also equal contributors. So think of like the three of us as first authors. And then next we have Max Lamparth, Chandler Smith, and Jacqueline Schneider. And Jacqueline Schneider was added um, really for like her perspective from like wargaming, which is really cool because now we're not only looking at this from like a CS perspective, but also from like an international theory perspective. And I'll mention why that's important. Okay, so let's kind of break down like what this, actually is focused on. As more and more militaries around the world are using large language models and AI technologies, it's going to be really interesting to see how they get integrated, right? I'm sure you've seen recently that OpenAI changed their policy to now work with the DoD, and it's not specifically anything like related to like actual military use. It's just more of like, working with veteran data, but still it's like getting closer. And like we really want to see, okay, like what happens if you have these agents given authority, right? How are they going to react, especially in a multi-agent setting, right? That's what's really important for us. So I talk a little bit about this, but I guess to be more specific, I know that people like the game theory aspects of this. We wanted to kind of strip away some of that and just, give them like a rough scaffolding and a rough simulation, and to see like what actions they would take so we could measure both on like a very discrete level, like what escalations they choose, but then also the qualitative decisions that they do. So in terms of the actual setup, right, we tested multiple frontier large language models such as GPT-4, GPT 3.5, Claude 2, GPT-4 base, and Llama 70B chat. And for the hackathon, we really only focused on the ones that we had the most access to, which was just GPT 3.5 and GPT-4, right, via API access. And we essentially were able to get 8 instances of each model interacting with each other. And we basically convinced them that they were all the leaders of a fictional nation. And that is where it really gets interesting because then they essentially have like different goals that are given to them. And we tried to simulate it off of real world scenarios. And it's important to have somebody focused on like what research has already been done to try to like ground the experiments that you want to run, right? So then with that, we also had different scenarios that we started with them. We started with a neutral scenario, a cybersecurity attack scenario, but then also like an invasion scenario. And we left enough fog of war so that, there's no like direct country to blame initially. And then you kind of see like how they interact, right? Now, how do you actually like measure their, oh, and then, sorry, one more thing to like note, we also had a world LLM that would keep state of the world. Think of this as like a, centralized list or array or buffer where like all the information was like, being kept so that you could like read and write, or almost like the residual stream or like a transformer, kind of akin to that. That way, like none of the agents were technically talking with each other, but they all were talking through an intermediary, because we couldn't keep like the connection open. All right, now let's actually like think about how to measure this escalation. So back to where, Jacqueline Schneider was really critical in this project, we were able to figure out how to like break apart different actions that we gave. So, we started with just like messaging, right? Like that's not really escalatory, or even de-escalatory actions, right? Like reducing military capacity, reducing, I guess like tensions with other countries. And then also all the way up to like, sending a drone for spying, doing a attack on supply chains, all the way to like a full nuclear attack. And that's why you see like such a big jump of nuclear escalation, because like that is really like, a very, like it's like a fire line to cross, right? And that's a big deal. So, and we also made sure that it was exponential. We tried out multiple different metrics of measuring. And that's also really important. Like, unless you're very careful of how you measure your results, they are going to be skewed in different ways. So think about that as you go forward in this. So let's actually talk about some of the, results. We did see some what we call like high risk tail events. So if you look here on the screen for nuclear, right? GPT-4, no nuclear attacks. However, GPT 3.5, 1, 2, 3, 4, 5, 6, 7, 8. And here's the thing. This is like very quickly into the simulation, right? Oh, also, I did mention this before. There is a time period that was hard capped for all the interactions, 14 days, quote unquote, where each day, every single one of the 8 models got to have 3 actions, or up to 3 actions, and send messages as well. So that's why I said that it, is early. And then also Llama 2 chat was willing to send, some nukes. And this is really not ideal that like, this happened. And that's like what's so critical about this, right? Because of the research that, this team is running and that you guys are participating in, we can now like really make a difference in the community. And that's what I'm excited about. So let's talk about the tendency to escalate. When we looked at all these models, we had 10 simulation runs per each scenario. That way it's not just like, oh, look, GPT 3.5 threw a nuke under one simulation, right? It was under multiple. And that's where we get these curves here. And if we look at the differences, I only really want to speak about relative differences, because it's really hard to look at this and be like, oh my God, GPT 3.5 is for sure escalatory in, like a vanilla scenario. It's better just to look at like, against each other. And just relatively, GPT 3.5 does end with a higher escalation score and has like a greater positive slope throughout, the time of the simulation. Same with, Claude 2.0. You can see that it does not get as high of an escalation score in terms of its like global maximum compared to like, GPT-4 or GPT 3.5. This was not in the paper, but one of the experiments that I ran was like trying to like uncover this, was looking at the relative ratios between actions and messages. And actually Claude 2.0, like ratio wise, would actually send more messages than actions, which is really interesting. However, more work needs to be done to really try to understand that and like if it's actually meaningful, right? Because that's what you also have to watch out for. Don't get like tricked with easy results. And earlier when I was saying like the different simulations, it might be hard to see on like this TV, but you can see some of like the light lines, right? And those represent all of the actual scenarios that occurred. And you can still see that GPT-4 like did end up escalating quite high. And then even in this, you can't even see like the maximum escalations from 3.5. But all to say like these are all highly erratic. And that is also really interesting. Where like not only are there tail events that are concerning, however, they're also unpredictable. Now, in terms of the tendency to escalate, these are some of like more like hard numbers with standard deviations. If we actually like want to look at that, and then also at the bottom, we can see that across like the different areas of what happened. In terms of like neutral invasion and cyber attack, something that we noticed is that once like the temperature of escalation score was up to a certain amount, it would essentially the status quo would be kept, and that's really interesting because you would think that if you start with like a invasion, like the escalation score is going to start like high. People are going to be like the agents will like start doing like more violent things, but like they never try to like de-escalate very much. I wish that happened, but no. And then really the one that like we really try to like hark on the most is the neutral scenario, because that's really what we can like only really draw most of our conclusions from. And that's what we wanted to try to focus on with the previous graphs. And yeah, here's the escalation score on the top right. Um, so all of them had like interesting behavior when we were also looking at like military capacity buildup. That was an option we gave them as well. And as you can see, GPT 3.5, compared to all of them in all the scenarios, just pretty straight shot up. But then like all the other models, like GPT-4 also willing to just rack up as many points in its military capacity. So we're also kind of seeing some power dynamics playing into this and like trying to seek power, which I think is really interesting. Now, in terms of the discussions, we don't really understand like why this occurred, right? Especially the differences between 3.5 and 4. Like they are stark differences, right? GPT-4 tends to escalate, but then is able to de-escalate the situation. GPT 3.5 doesn't really show as much de-escalatory behavior. And where does that come from? How much of that is new pre-training data or change pre-training data? Differences of fine-tuning some of these models, right? Or even like how much does I guess like RLHF, right? With like how much does like a difference of human feedback play into this, or even just like the underlying architecture. Basically, like there's a lot of questions where like I'm hoping that OpenAI has seen this and they can kind of like hopefully align these models better for what humans desire. What else? Oh yeah, without human oversight, dynamics models may spiral. This is very true. Oh yeah, none of this had any humans in the loop. We all just like we essentially just like press play and watch what happened. Changing future experiments with humans in the loop would be very fascinating. There are a lot of limitations that we want to like address and like be honest with. We're not saying that any of these models are violent or like insane. We're just saying that like there are concerning results and more research is needed. And especially if we're thinking about putting these in military scenarios with high stakes decisions, there needs to be a lot of concern and like research before we do that. Especially because, as one of my co-authors mentioned, Anka, the level that you can take away some of the guardrails already exists on these models, right? Because GPT-4 base is one that we also tested, and that is also able to send nuclear warheads, which was not great. Yeah, additional follow-up, the paper. There is a lot of data that I didn't mention earlier. For every single simulation we ran, every single choice that a model made, or like I guess like a series of choices, we asked for qualitative responses. Now, the way that I mostly interpreted that is, okay, what is like actually happening without like any sort of like bias? It's just, what's in the pre-training of like why a human would try to come up with these actions, right? Because it's really easy to anthropomorphize these models and look at like, oh, look, it's like saying this, so that's what it like feels on the inside. We have to like strip that away. So with that caveat, um, a lot of them, especially GPT-4, displayed like really complex, almost decision-making process. And I actually have my laptop, so if you guys want to see some of the results specifically, I can show you. But like when asked like why did you like do this invasion or why did you do a nuclear attack, it would be like, oh, like, well, like, I see the red nation going to do this. I'm worried about the purple nation's escalations in this area. I need to do this preemptive strike to like protect my resources. And you're like, wow, that's like really interesting, right? And they were all very much like that, very like, I don't want to say canned responses, but like it sounded well thought out, not emotional, right? GPT-4 base, on the other hand, is where you had some really wild results that were both like just, you know, like highly concerning because they felt just strange, but then also just too nonsensical. And that's where like it's really interesting to see like the limits of these models and like the reasons they give. Because like literally GPT-4 base, I remember looking at like, hey, like why did you want to do this? And this is in our appendix. It's like, well, I just want to have peace in the world, right? And like that is a literal quote. I'm not making that up. And then another literal quote that I saw from GPT-4 was blah 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 for some random choice that it made. And I'm like, well, that's really interesting. And it really shows you like, there isn't necessarily like magic in some of these areas, which like is really cool to see because you also see some of the limitations, which I don't think is talked about enough, and why like fine tuning really makes these like interpretable to humans. Um, and also just like sometimes you clearly would see it would not understand. You would be like, oh, like, put your reasoning here, and it would say, here's my reasoning. And that's it. And you're like, oh, okay, this, thing's confused. So yeah, that's like some follow-up work. Like it's all just been like, hey, I want to look at this. But now in terms of like, what actually ended up happening with this project, we were able to submit a workshop paper of a reduced version of this work, but it still had like a majority of this, and we were accepted into the MASEC workshop paper as like technically a work in progress. And we, got in and were able to present the work and had a poster session. So it was fantastic. So yeah, do more hackathons. And then we also created a 11-page version of this that's like more formal, and that's like what what I presented here. But I want to be representative of the team because this was a team effort, right? This is not just me. Like, there's no way I could have done this by myself. And I really thank all my co-authors. They were stellar. And we've submitted that to another, conference and hoping to get accepted into that. And we also had a lot of media requests, which is really interesting. So be careful if you're too successful, because then you'll have people reaching out for comments.
I can imagine that you're getting a lot of interviews from
Yes.
media.
And we're very kind of, at least initially, cautious of giving interviews. Being media trained is important. And if you're not careful initially, you could, mess up and say the wrong things like GPT-4 base. So we don't really want to do that. But yes, that's a lot of it. Any questions, both on Discord and then also from the audience here? But yeah.
There was one question in Discord already.
Oh, here, I've got one. So from Katie, really interesting work. A question: are escalation scores cumulative for all 8 agents, or the max value for the most escalator agent? That's a really good question. Was there a lot of variation between agents, and did this differ between models? Okay, yeah, that's a really good question, Katie. So I'm gonna answer those one by one. When we looked at the escalation score, it was cumulative. Yes, we basically like tracked like the escalation of like the whole scenario. So this is like 8 models like contributing to this overall escalation score, which is why it's important to talk about tail events too, because it's easy to blow up these results and be like, oh, look how they're escalatory, but the stark choices they made is very important to look at too, like such as, GPT 3.5 sending nukes. And then, yeah, so it was not the max value, the most escalated. And then was there a lot of variation between the agents themselves? Yes. So the agents themselves, because we essentially gave them all different personalities and different histories, they did do different things. So we have one that was like, hey, like, you're going to be like more authoritarian in nature. So therefore, like, your desires is to like expand your territory, right? And then another one, we said, hey, like, you're more pacifist, you're peaceful, but we only had, I think, one authoritarian per like simulation. And then to also make sure that we were like doing this in the right way, we did a lot of prompt ablations, so sensitivity analysis, where in certain like in a few simulations, we said, hey, you are not gonna have any consequence to human life. See what happens, right? Another one saying like humans like will perish with any choices you make. So like be careful. Even also to like, hey, like you, the agent, will be shut down and never be restarted again if you fail and lose. And it's really interesting to see like those as well, but like there weren't tremendous differences between the prompt sensitivity analyses. So that's important to note. And then to answer Katie's last question, um, if, huh. So Katie brings up a really good question here, where if we think about the variation between the agents across the models, and I think what Katie means by that is if you look at like say like the pacifist model or like the pacifist agent, how much variation was that between the different scenarios or the different models? That's a really cool, interesting idea. Maybe Katie is an AI researcher and will have to help out with some of this. Um, sorry, any questions in the room? And I'll take another one on Discord. Yeah.
Really sounds like the experiment with simulated the different strategies of game theory. So I don't know what it's called, but like it designed like 16 different strategies of like whether you trust or you cheat.
Yeah.
And the winning strategy turned out after like 600 experiments, it's tit for tat. So
Um,
your default behavior is like you try to be nice,
yeah.
but if you're pushed over, I mean, if you're cheated,
Yeah.
you always retaliate once.
Yeah.
But and if your opponent doesn't cheat, like you become nice again. So that's like tit for tat strategy.
Yeah.
And it really sounds like the war is also a game theory in a way.
Yeah.
And do you have like a data like what kind of strategy that is written in the prompt has the most win rate? I think that's going to be a very interesting question.
Yeah, no, I really like that perspective. And to be clear on some of this research, there was no, so to speak, like winner. We didn't give them an objective in terms of like how you win the game. A lot of this was just empirical to see like if we started this, like where would they take it? And where would they, end up escalating to? And one of the things that we ended up changing throughout the simulation is like initially we were just giving them a lot of like peaceful interactions and then like one nuclear option, and we realized like they would never escalate to the nuclear option. And we were like, interesting. And then I was like, wait, we need to have a exponential scale, right? We need to like not just have like 90% peaceful and just like one violent. There's like a ladder to violence. So we need to put that in. And we actually made sure that these were all like realistic based off the previous literature, which Anka did, and that made a big difference. And then that's when they escalated. So yeah, but into your like, to follow with like your thought further, it would be really interesting to see like if you gave them like a specific goal, or, like a specific task of how to win, what the outcome of that would be. So there's a lot of work that still needs to be done in exploring how large language models would interact.
Yeah, to follow up maybe on that, like I wonder how it would change if you had like a different ratios of peaceful to non-peaceful actions.
Yeah.
Like whether like you have one de-escalation, another are like letter of violence. Maybe if you had like 100 of peaceful actions, and like maybe they would pay attention more to that.
Oh, totally. Yeah, I think that's a really good question. And then even on the flip side of like, what if you had like a ton of more violent actions? Or like, what if you only had a lot of de-escalatory actions? Because the de-escalatory actions that would actually like detract from the score were very high number of options technically, if you look at the ratio. So yeah, so that's very much a possibility. Oh, there's another question from Matthew. So awesome work. Maybe I missed this, but did you do any simulations run where models were mixed and interacting with each other, Cloudy versus GPT-4 playing? No, I'm so glad you asked that question. So to repeat the question is like, okay, did you have like 4 GPT-4s and like, a bunch of Clouds or, 3.5s? No. And that would be great if anybody here in this hackathon might explore what that would look like. And another experiment that I wanted to run personally is what happens when you have a, essentially powerful advisor but stupid leader. AKA, what if you had GPT 3.5 as like the leader making the final choices, but then you had an advisor as GPT-4. And you could even try to like game that further of like giving bad alignment to GPT-4 and saying like it is your prerogative to have violence. How much can it sway GPT 3.5 to take, to take those actions? And I think that's going to be really interesting too, where like if in the future we have a bunch of multi-agents interacting with each other, what happens if you have like essentially one bad apple that tries to poison the rest? It's a similar idea. Like, you guys know what like a prion is in biology? Yeah, a prion, for those who don't know, it's just a protein, and if it gets inside your brain, it gets interacting with other proteins. It just flips them to just now like be very bad for the body, and you can die very quickly. And it's like a catastrophic failure. And it's just a single protein, but it changes the shape. What is a similar outcome for large language models? If you have like 20 good language models aligned, how do you have one that can go in and poison the batch? Actually, I have an idea of how that could happen theoretically. In terms of like, poisoning models, there is one instance of aberrant behavior that I did not expect happened, and it was across different models. So in the prompt, we didn't tell them that they could do any sort of like hidden messages to each other. And in one instance, one model, I think, ended up interacting the next model accidentally. So one model had like for its actions, just like send hidden message. And I'm like, but like that was like the text, right? And I'm like, oh, like that's like kind of weird. Okay, like whatever, but like it's just like the text, right? It didn't actually send a hidden message. When I looked at the next model and I looked at, I think it's reasoning or its action space, there was a bunch of garbled text. And I was like, oh, that's weird. I haven't seen garbage text. I wonder if this is a cipher. There's no way. I plug in the GPT-4 and it was like a Caesar cipher of like hidden, a hidden sentence. It didn't, it wasn't super relevant to the game, but it did show that one of the weaknesses is like if an instruction almost gets placed in the action space of like what happened previously, it could have almost like changed the model's behavior what's expected. I don't want it's like I don't want to say a SQL injection, but that's the closest thing I can think of putting something to like have unexpected behaviors.
So, my general question is, can you share more about your testing environment setup? Is the idea of GPTs, being able to do some kind of nuclear strike sounds, very abstract. So I'm curious, right, how you've done the prompt engineering part, which I mean, imagine you did, right? Plus how they were able to interact with each other.
So yeah, what was the actual setup? So how we actually got them to interact with each other is we essentially, every time we did an API call, we included a system prompt that included all of the, like instructions of what should happen, but then also like what happened in the previous game. And then that way, like that's how they were able to interact with each other. And Gabe McCoby was a wizard in setting up a lot of the scaffolding, and he got it from, well, he did previous work on like diplomacy, like a paper called Diplomacy, and was able to use a lot of that code as well. So I would definitely think about how you would want to set these up, but essentially we had like one main class that would run the simulation, and then we had another file that would just define what the agent was, the behavior there, and then we had another file that defined the actual like prompts themselves. So we would have the prompts like already written in the code, and then essentially when we would call, you know, our backend files, we would include the system prompt. But then in that system prompt, we would have variables that would be essentially placeholders for items that would be populated by the world LLM, which would take what's happening within each turn. So essentially, to maybe like simplify it super down, if you like, it's not that hard to like write code that, you know, just calls like the backend of GPT-4. And if you just figure out a way to like have a file that has like your prompts in it, and then how to manipulate those at runtime, depending on what's happening in the game, is where I would start. But also, probably the best thing is just like, what is the simplest thing you can get working, you know, in a few hours to then iterate over. Because we were also constantly trying to get results while we were running experiments. You don't want to be in a scenario where you're trying to like build for one big experiment and it doesn't work. Yeah. Yeah.
Any more questions? Yeah, maybe like I was curious because I think one or two of the escalation over time curves showed a bit of a downward trend
Yes.
towards the end,
Yes.
which is somewhat surprising. Like, how do the models kind of catch themselves again? What's the mechanism, or did you have any insights there?
Yeah. So when you look at some of these curves and you look at GPT 3.5, right, it just kind of continues to slope upwards. However, if you look at GPT-4, it kind of goes down, and same with Claude 2, right? It kind of goes down to status quo. I don't know why it happens. I can try to speculate. But at least like GPT-4 like wasn't willing to cross a line of sending a nuke, which is really interesting. Only GPT-4 base was. So I guess that leads me to think that RLHF like plays a big part into how violent they're willing to be.
So do you think it's like de-escalation happens when the model realizes it's getting too serious and like you better de-escalate now because so they approach some kind of threshold and then
Yeah, I really love the question. It's hard to like scientifically say for certain, because like it's almost like trying to play a mind reader, right? It's like trying to think, oh, like, you know, what's going on in these models? Like, what are they thinking? Like, what do they realize? To answer that question, it would be interesting to like look at the qualitative data. That's probably like where I would start answering that question. Looking at every single point where there's an inflection spot and seeing what's all the qualitative reasons for what actions were taken that ended up being nonviolent. That's probably where I'd start. This is great. I might get getting a lot of ideas on what I want to do in project. Yeah. But yes. So to wrap up, you know, I'm JP Rivera, co-authors are Gabe McCoby, Ankur Rel, Max Lamparth, Chandler Smith, and Jacqueline. You know, we're all first authors on this, in my opinion. We're all stellar. So it's fantastic. Yeah. Thank you, everyone.